Okay, hi everyone, and welcome to the monthly seminars of the Big Data Health Science Center. The title of this seminar is Twitter Drives Measures of Sentiments Toward Minorities. This seminar is hosted by the Social Media Corps. I'm happy to introduce Dr. Quinn Nguyen. She's an assistant professor in the University of Maryland School of Public Health, and her research interests are social media analysis, creating and validating neighborhood indicators, and social media and social epidemiology. She has published several papers on using social media for health, such as building a national neighborhood data set from geotagged Twitter data for indicators of happiness, diet, and physical activities. She has awarded several grants, including 2 grants from NIH K1 award, and then 1 R1 award from NLM, or National Library of Medicine. So we are so excited to have her in our monthly seminar. Before we start the presentation, please type your question in the chat box. If you click on the chat box, you can type your question. And then at the end of this presentation, you're going to get 1 survey, and we would be very happy to get your valuable feedback from you. So that's it. And Dr. Quinn, the stage is yours. So I'm going, to stop my screen sharing. And then now you can start your presentation. Thank you so much for accepting our invitation and being in our monthly seminar.
Oh, yes. Thank you so much, Amir, for inviting me. I'm very happy to be here. It's a long time coming. We were actually scheduling this webinar before the pandemic hit. But then, of course, it had to be canceled because I was supposed to fly there. So I'm very happy to finally, get to present in front of you. I always like to talk with students and other faculty members because, feel free to, if you have questions when I present, clarifying questions, let me know. You can raise your hands or type them into the chat. And then we'll have more of a discussion also at the end. But definitely let me know if you have any questions as I go along. So I'm going to get started. I'll share my screen. Okay, let me know if you can see it. Is it okay? Okay, so
Quinn, can you put it in the presenter mode?
Yes. Does that look good?
Yes, perfect.
Okay.
Thank you.
Yes. Okay, so this project is covering the use of Twitter data to examine sentiment towards minorities or racial climate. So I'll start off with some background information. There's as you know, different forms of racism. We have institutional or structural racism. So that's where we have policy laws that affect how individuals are treated. And then we have cultural racism, which is social norm, the language, the unstated assumptions of society. And this, I would say all of these different types of racism differ by societies because institutions differ, culture differ. So I would say these are place-based constructs. And then there's also individual, as you know, individual level discrimination. And in the literature, you find a lot of the literature focus on this level, where you have surveys asking respondents, have they experienced inequitable access to opportunities like education, housing, healthcare. So you find a lot of focus on that. But what we're trying to use with social media is actually trying to cover or try to assess for cultural racism, which is the larger society, the social norms. And as you know, Twitter is kind of as a researcher, you can kind of think of Twitter going into a public square and just listening and into like conversations and trying to understand how people are talking about different things, different concepts. So that's how I conceive of Twitter, and from those conversations, we try to extract indicators of cultural racism or area level racial climate. So race and health, there's like a really quite substantial link. Different investigators are looking at how racism can set up like a social context. And that context can be with like a society that has a lot of racism could exert psychological distress. That can serve as a chronic stressor for people. And then that leads to, as you know, like stress can lead to unhealthy behaviors and then adverse health outcomes. And so the series of studies I'm going to present is looking into racism, racial climate, and its relationship to birth outcomes, as well as subsequent outcomes like cardiovascular disease that's also triggered by stress. So previous literature has looked at racial disparities in birth outcomes, but that's not completely explained by things like prenatal care, social demographic characteristics, or health behaviors. So there is this unexplained component. And one of that unexplained component could actually be racism, because people have looked at, for instance, after the 9/11, people with Middle Easterns, people with Middle Eastern sounding names face more increased harassment and violence and discrimination. And people found that women with Arabic sounding names had increases in adverse birth outcomes like preterm birth and low birth weight. And then in the literature regarding the birth outcomes of Black women, there has been like people found like 2 to 3, for instance, fold increases in adverse birth outcomes with self-reported experiences of discrimination. So there has been a history of like linking racism to adverse birth outcomes. So what this differs is we're trying to create indicators at the area level to try to understand the climate of different places and then examine the potential links between area level racial attitudes, racial climates, and a variety of outcomes. So you belong to like, this is like, we're talking about social media. It's like preaching to the choir because you're all interested in social media. What we like about Twitter data is it's timely, it's cost efficient, and the way Twitter is set up, it's actually very friendly for researchers because they make their API freely available. And it's only capturing publicly available tweets. So tweets that people make public. And also, as researchers, we are also mindful of like people's privacy. So whenever we present our research, we do it, tweets are aggregated, and often they're aggregated over a year period. So nobody is like identified. And even if they're like, we don't post in like individual level tweets, and sometimes for qualitative analyses, sometimes there are example tweets that are posted, but then we change the content so that you can't search for it. So as researchers, it's good to be mindful of protecting people's privacy. The majority of results are going to be summaries over the state level for a whole year, so you can't identify anybody. And when you try to give example tweets, you will we try to like change it so it's not searchable. So that's it's moving forward as researchers get into this realm. It continues to be important to try to protect people's identities, knowing that if we do a research in a way that's intrusive, then we will taint the very exposure data that we need. So I always try to be mindful of that as I'm going forward. We also like Twitter because it's unstructured text, so it gives us like a range of like, it allows people basically a free form way for them to like express their opinions and views, which we try to characterize. So this first study was started, we started this work in 2015, so it's pretty long time that we've been working in this area. So we used the Twitter API for about 1 year to capture random sample of tweets. And then tweets have a latitude longitude coordinate that are assigned to them, like of where the tweet was sent. And we categorize, the places of where the tweets were sent. We started with a list of about 400 racial terms and also racial slurs. And this was obtained from like the US Census as well as an online database of racial slurs. So it contains neutral words as well as racial slur words. And then we use Python software to perform sentiment analysis. The first classifier that we used was the stochastic gradient descent classifier. And this one had like a good accuracy at 89%. So accuracy just means our team manually labeled tweets and we compared it with what the algorithm was predicting, and the match was around 89%. And we also use label tweets for training. So in this type of supervised learning, you kind of have tweets that we labeled as well as we aggregated tweets from other teams, and then we feed that to the the algorithm so that it understands how to distinguish between like sentiment, and then the model is able to perform and predict on tweets it has not seen. So the health outcome data come from the 2015 natality files. So this composes like the vital statistics that are released yearly on all births that occur in the United States. So in 2015, there were close to 4 million births. And then we looked at low birth weight, very low birth weight, and preterm birth. So the definitions are just right there. So low birth weight is anything less than 250, 2,500 grams. And then preterm birth is if the baby is born with gestational age less than 37 weeks. So these are the percentages. Preterm birth is at around 11% prevalence, and then low birth weight is around 8%. Among the mothers that gave birth, about 53% were white non-Hispanic, and 77% were born in the US. So we do have some diversity here in the birth data. So the analytic approach is to summarize Twitter data at the state level and use like really simple adjusted Poisson models. So the outcomes is coming from mothers, so mothers' birth outcomes. So there's like 4 million observations, and each individual has like a state Twitter-derived racial sentiment variable. So that's the main predictor, like the mothers living in states with various racial sentiment. And then the model's also controlling for other state characteristics like state level expenditures on public welfare, and percent non-Hispanic white and median household income. And this is just to control out for some factors that might compete with or confound the association to racial sentiment and health. For instance, like states that have more racial hostility might have less spending on public welfare. So we want to control that out to say that, controlling for those other state level characteristics, what is a potential association between, state level racial climate and birth outcomes. And we also control for individual mother's characteristics like her age, sex, ethnicity, foreign birth, education, marital status, smoking, BMI, birth, like if this was a first birth, and her prenatal care. And so this is all trying to control out for things that because we want to isolate the potential association between racial sentiment and health. So we try to control out for these confounding factors. And I guess what's also good to know is that these factors are available in the births data, and the births data is publicly available if others are interested. It's like a really rich data set. So I would encourage people to use it if they're interested in it. So this is just the distribution of like the different race mentions. Remember, we had like 400 race terms. And so over half of the race tweets were about Blacks or African Americans, about 200,000 are about Hispanics, 270,000 about Asians, and then Middle Easterns around 60%. And then there are also other race groups like immigrants and refugees. They're a smaller amount. This is the terms that are most popular. The different terms. I would say the NIGGA term is really popular, and when we read into it, it's like usually used as a pop culture reference. The other version of the term NIGGER, that is very low because that's very negative and right, it's a racial slur. But that other version of the term is very low at less than 1%, which we were happy to see. And so these are just like the terms that are used in the data set. I would say like the racial slurs, although we included many of them, so if someone posted about them, they could be in our data set, but they were actually really low. The majority of the terms were neutral, but then they start off neutral, but then we run sentiment analysis to try to understand the context in which the term is used. So to give you a general idea, in general, about 19% of tweets are positive. And then most of them are going to be neutral, and then like 6% are negative sentiment, so sad. That's just on the general characteristic of the tweets in 2015. But like when you bring race into it, so if a tweet mentioned like a race group, and in particular if they mention Black related tweets or Middle Eastern related tweets, those have like more negative sentiment. So here it's percent positive is lower than general tweets. And Hispanic and Asian related tweets are have higher positive sentiment. But I will go through time because at the end of the presentation, I'll also discuss, like, as we know, anti-Asian sentiment during COVID. So we have been studying that, and there has been a rise in anti-Asian sentiment. I'll try to cover that at the end. But this is like the first presentation, just looking at the different sentiment groups, racial groups, and sentiment associated with them in 2015. So we can do like a geographical map where we're looking at different sentiment distributions across the United States. And so more positive tweets are dark color. So we see that, for instance, some of the East Coast and the South have less positive race tweets. And that's in line with literature finding that, hate speech is more prevalent in the East Coast and also South. So I would take this with a grain of salt. So for instance, states with the most positive Black related tweets are like South Dakota, Wyoming, Utah, Oregon, New Hampshire, North Dakota. But like some of these states like Wyoming have very few tweets. So I would take it with a grain of salt. States with the least positive tweets are Vermont, Louisiana, Mississippi, Alabama, District of Columbia, and Connecticut. So East Coast and kind of South. Okay, so here we're looking at the 4 million births that occurred in 2015. That's the outcome. And the predictor is state level racial sentiment. And here, like for instance, the first predictor is percent of Black related tweets that are positive. So states that have very low positive racial tweets when Blacks are mentioned have increased in the risk of low birth weight. So there's 6% increase, also 6% increase in very low birth weight, and 10% increase in preterm birth. And the first column is showing all births, and the second column is showing like births among minorities. So this is restricting to Hispanics, non-whites, and foreign-born. And you see a little bit stronger set of associations, but not much, just a little bit stronger. And we also look at tweets that have that are Middle Eastern related. And so we see again that mothers living in environments with fewer tweets that are positive when a Middle Eastern group is mentioned, then you see increases in adverse birth outcomes. So those are the two groups that had like associations. Tweets that mention Hispanics or Asian Pacific Islanders, that generally was not associated with. There's some association, but it's much less strong. Like there's some associations with like Hispanic related tweets being related to adverse outcomes, but not as strong as for Black and Middle Eastern related tweets. So here we're looking at, we kind of do sensitivity analyses where we have like geotagged tweets and non-geotagged tweets. So we notice that they're much more non-geotag tweets because people don't necessarily want to enable location. So we want to check for a selection bias to kind of see like if we're restricting it to people who enable location, and that's a smaller number of tweets, are we inducing selection bias? And as you know, like selection bias is when your sample is not really representative of your target population because there's like characteristics that are different and skew them in a different way than, you know, the full population. So we see that luckily when we look at geotag, the associations with geotag tweets and the study results with all tweets, we see pretty similar estimates. So like for instance, 0.92 versus 0.91. So it's robust to like, you know, the tweets that have location. So we were happy to see that. So here the first study is looking at, there seems to be wide variation in sentiment towards racial and ethnic minorities. This is kind of like demonstration of like that social media seems to be able to assess for racial sentiment with satisfactory level of accuracy, as you saw, like actually was 89%. And mentions that have like Blacks and Middle Easterns in particular seem to be associated with worse outcomes for minority groups as well as the full population. And I'll continue, but there are some limitations. So these were cross-sectional analyses. And what we're getting at from Twitter data is not direct experience of discrimination. We're trying to understand like the racial climate, like the larger social cultural influences, the larger society, the social norms around that, and not necessarily direct individual level experiences. Okay. Oh, sorry. So I had someone ask, was that data set free? Yes. So the data set, so definitely feel free to like ask questions throughout. So all the data sets that were obtained were free. And we kind of made a point to do that. So Twitter is free to use, like we use their free API, and then the vital statistics was also free. So both are free. If you want the vital statistics that have like county level identifiers of where the women gave birth, you have to kind of submit a data use agreement, but that is free. So there's just a little waiting period while you wait for the data use agreement. But yes, all the data are free. There's the Twitter API and then the vital statistics. Okay. So I want to just provide a quick update with more years of data. So here we are boosting it up to like 26 million tweets and over 2.5 million Twitter users. And we also increased the race-related keyword to over 500. So as you saw in the last iteration, there were like 400 race terms, but we kind of wanted to be as comprehensive as possible. And we grouped the racial terms into racial ethnic categories just so we can track them. The same, you know, birth outcomes were applied and examined. And here we have like 10 million births, whereas before we had like 4 million births. We use a different sentiment classifier to kind of get even greater accuracy. So accuracy now is like 91%, and F1 score for those who are interested is 84%. So we use a machine learning model to do sentiment analysis that boosted the sentiment accuracy even a little bit higher. Okay, so we use log binomial models, which are similar to log Poisson, controlling for individual level maternal and state demographic characteristics. So this is just like a map, but here in the previous map, we show like positive sentiment, and here we're showing negative sentiment. So it's robust to showing both because we see the same pattern where you have like more like negativity surrounding like race-related tweets in some of the East Coast and South. Here we have the prevalence across the 3 years, 2015 to 2000, a little bit of 2018. So you see the prevalence of happy race-related tweets start to decline for most states across that time frame. Oh, I see another question. Okay, another question. So how can you validate Twitter data is not misinformation or disinformation? So this is a really good question. I would say like for the concept of race, misinformation, disinformation, like it is not as important to our study aims, as if you're researching a topic like vaccines or like something that has like that you really do want to track if people are like spreading misinformation because it's false, and that could lead them into different health behaviors. But what we're trying to get is like, even if someone is like saying things that are false about race, that is still like relevant for us because it's like capturing people's potential like wrong statements, like biologically wrong statements, but also like we also capture it. That the wrongness of the statement is not so much important to us as if the statement contains like a negative overtone, because like the negativity is what we're trying to capture, because we think that is the thing that or negativity or actual racial bias or discrimination, that's like the content that we think is going to be relating to adverse birth outcomes, and not the truthfulness, because like people will believe varying like fact-checked truths about race. That's not so much important to us, but it's like the racial bias and discrimination that are things that we're particularly interested in. So let's see. And the prevalence, I'm not sure if I present on, if I show some example tweets. I can also kind of tell you, oh yes, I do kind of give you some examples of tweets towards the end. But the tweets are like, the content of these tweets are like different buckets. So some people will just talk about everyday life. Some people will talk about certain events. And so that's kind of like mainly what they share. Like the bulk of what they share is like everyday life and sometimes sharing of events. So that's like the main content of race-related tweets when a race word is mentioned. Okay, and then so we see the prevalence of sad race-related tweets also increase across this time period. Okay. So another question was, it's an important one. So how do you determine the authenticity of Twitter data? So, as researchers, we always worry about like data quality. So we do various like sensitivity analyses to try to understand that. In particular, like we've done sensitivity analyses where we get rid of like users that post more than 1,000 tweets in a year that are race related. So our data set only pulls a 1% sample of tweets. So like if a person somehow gets in our 1% sample and they have more than 1,000 tweets that are race related. So race related, like, cause they can tweet about anything like food, physical activity, like, anything. But if they are posting like 1,000 tweets about race in a year that make it to our 1% sample, that means they're tweeting a lot about race and they might be a bot. So in sensitivity analysis, we like exclude users that have that high level of like tweeting because we don't want them to overshadow the other users and have them like be too dominant in the outcomes that are like because if you have a heavy hitter like that, they might like sway results unduly, and they also might be a bot. So that's like one set of analysis, like sensitivity analyses, where you can kind of get up like really heavy users that might be a bot, and like you don't want them to have undue influence on your results. So when we do that sort of analyses, we find that it doesn't affect the overall associations, because even if we take those heavy hitters out, there's like over 2.5 million Twitter users in our race-related data set for this study. So even like some people including or excluding them, it doesn't really matter. So that's like one set of sensitivity analysis you can do: exclusion for bots, exclusion for heavy hitters. And also like with time, as you notice, we've expanded our keyword list to be even more comprehensive and try to capture as many race-related tweets as possible, because we included misspellings, we included informal language, knowing that Twitter is like a special space, right, where informal language is used, where slang is used. So you kind of have to know your data set and know what words can help you capture the topic that you want. We also progressively look at different machine modeling techniques to try to increase accuracy to as high as we can get it for racial sentiment. And like racial sentiment models are out there, and you're like, people like, this is like a firm area of study for computer science. But you will notice that depending on the text data that you're giving it, it's going to have different accuracies. And because like the content of the text is different. And so you want your training data to be as race related as possible if you're interested in predicting race related sentiment. And so that's what we learned with time, that the more training data that's specific to what you want to predict, the better. And the more training data that you can get, the better as well. And there you can choose from different models that will give you different accuracies, and you can compare the different accuracies in F1 score to kind of arrive at the best prediction that you can get with the resources that you have. Okay, so I'm going to quickly move on. So here are the results with the expanded birth data and also expanded Twitter data, and it's robust. So we do see increase, like more negative sentiment associated with worse birth outcomes, so more low birth weight, more preterm birth in the total sample, among minority mothers, and among white mothers. So this is something that was repeated because we saw this in the 2015 data, and now we see it again, including 2015, 16, and 17 birth data. So I think a lot of the literature on race and health don't really take into account potential outcomes among whites, because they're focused potentially rightly on minorities because they are the victims of racism. But what we're finding is, yes, there are adverse outcomes for like living in areas that have more racial hostility among minorities, but it seems to also have adverse outcomes among whites. And this made sense to us because the racial climate is like a chronic stressor, and it can like be a chronic stressor for minorities. It's also for whites, and living in an environment that is like racially divisive also worsens things like social support and collective efficacy, which are known to be good for health. So if you live in an environment that, there's open social support, so high social cohesion, people take care of each other, people feel like there are other people that they can rely upon, that is generally associated with better outcomes for the population. And an environment that is like divisive will negate social cohesion, collective efficacy. And so that's what we think is happening here, but it's like a hypothesis, but we're seeing associations worse for minorities as well as whites. Okay. And then I'll continue on to the next slide. Here we also looked at like race-specific sentiment and race-specific groups. So for instance, we looked at like speech around Middle Easterns and whether that would be associated with an adverse birth outcomes among Middle Eastern mothers, and we do see that. So it's like it's race sentiment matched with the race of the mother, and then we see that for like Blacks as well. But we don't see that for like if the tweet is like negative towards whites, we don't see an increase in birth outcomes for white mothers. So it's not the sentiment around whites, for instance, that seems to matter. It's like the sentiment towards like racial ethnic minorities. And I think one explanation is that the racial sentiment against minorities is so much more pervasive and like loud and apparent than potentially the racial sentiment for like whites. So I think it's like a matter of effect size and like prevalence. And here we're looking at time and how the association has differed across time. So the main point is looking at 2015, 2016, 2017, it seems like the adverse association between preterm birth and also low birth weight for Black mothers has like become stronger. So it has always been an adverse association. We found that out in 2015, but it seems like that association is even stronger in 2017 for Black mothers compared to the total population. So the total population, the association between like racial ethnic sentiment and birth outcomes seem to be a little bit more attenuated, as you see like the decline for like the total population. There's like a little bit decline, not so much, but like from at least 2016 to 2017. But for Black mothers, you see that the 2017 column, the pink one, is the highest, showing like the bump in adverse birth is the highest for 2015. And that bump is the difference between mothers living in states with the most negative sentiment versus mothers living in states with the least negative sentiment. So it's just association has become stronger over time for Black mothers. So now we're going to quickly look at, because just in the interest of time, and I also want to open up to discussion. So we have like cardiovascular disease outcomes that we looked at using the behavioral risk factor surveillance system. And this survey is publicly available, so you can use this as well. There's no cost to using it. And we control for individual and state level characteristics. And we see the similar with birth outcomes because cardiovascular disease is a condition triggered also by stress. We see that people living in locations that have like more sad race-related tweets have an increase in hypertension, stroke, MI, CHD, or any cardiovascular disease, which is like just stroke, MI, and cardiovascular disease. So we see like an elevation in risk. And because like sometimes people want to see like, is it true if you look at happy tweets? Like, so people living in areas with more happy race tweets see a decrease in these outcomes. So it's robust to whether you're looking at the prevalence of happy tweets or sad tweets. The directionality is that, you know, climates that have more racial hostility would be worse for cardiovascular outcomes. So this is looking at like social media as a way to measure social conflicts and investigate its potential influence on health. So I want to kind of get at some new work because, you know, during the COVID pandemic, we had like a lot of race-related things happening. So George Floyd and his killing prompted national, international scrutiny and like led to like, you know, the Black Lives Matter movement, like it's like the strongest it's ever been. So this study is examining how like conversations on Twitter following his killing, as well as the killings of other people, Ahmaud Arbery and Breonna Taylor, and like shifts in sentiment. So this data includes tweets that from November to September. Let's see if I can move it. So November 2019 to September 2020, about 3.4 million tweets. So, and also we looked at Google searches. I won't really delve into that, but basically Google searches are good, are mirroring what the Twitter data is telling us. So we conducted sentiment analysis, and we also did a content analysis. So for people who are interested in qualitative analyses, you can use that in conjunction with Twitter analyses as well. So, so for Google searches, I'll briefly say that the highest, the names George Floyd did peak in the week from May 31st to June 1st, the week after his killing. And then we looked at the prevalence of tweets referencing Blacks, and we saw a decrease. So there was a decrease in tweets that were negative that mentioned Black people. But this decline seemed to only be temporary. The decrease was around 32%, but it only lasted a few weeks following the murder of George Floyd. But we looked at racial sentiment also following the killings of Ahmaud Arbery and Breonna Taylor, and there wasn't substantial shifts. It seemed like the shift occurred for George Floyd. And we looked at the content analyses, so like qualitatively reading about 3,000 tweets. It seemed like they could be kind of divided into buckets. So some people talk about race or racism in positive or negative tones. Some people called for action. And then there's also counter movements, arguments against racism and related change. So there's always like, you know, there's always push and pull on Twitter. Okay, sorry. Let's go back to this slide. So this is showing, the blue slide is the racial sentiment. And like the different killings were happening, we're also showing at the vertical lines. So George Floyd's death occurred May 25th, and that's where we saw a dip in like negative racial sentiment towards Black people. African Americans, and the shift only lasted a few weeks, and it came back to homostasis after that. So that's our analyses for that. There was a there was a transitory decline, and this seems like saying that racial attitudes or racial sentiment seems to be deeply entrenched. But the Black Lives Matter movement, as we know, seem to have made and is continuing to make changes in that we are like culturally as a society, I think we're more aware of racism and more companies are taking a stand. Like you can see the media companies flagging content, like even Fantasia. I have a toddler, and now when we watch Fantasia, there is a disclaimer at the beginning where it says, you know, the views like or the content was wrong, like, you know, then and wrong now. So there are, you know, media companies, and just policies in general that have resulted in more structural and cultural changes stemming from the murders in like the Black Lives Matter movement that is continuing. Okay, we also looked at like anti-Asian sentiment. Sorry, I'm going to quickly move. Here we have like anti-Asian sentiment during COVID. Again, we kind of use the same body of tweets, but here we're looking at anti-Asian sentiment. So we actually see the proportion of tweets that are negative towards Asians increase like 68%. So it started with like 10% in November and it jumped to like 16.5% in March. So there's a spike in negative tweets that reference Asians, whereas the other tweets, like the other racial groups, didn't experience much of a change, like only 1 or 2% change in their like prevalence levels or percentage change. So the change for Asian tweets over the pandemic is unique to changes that occur for the other racial groups. And like we also qualitative read these tweets, and about 20% were about racism and blame, and then 20% were about like anti-racism, and then we're talking about daily lives and impacts on daily life. And here we're looking at like temporal changes, and you see a blimp, an increase in negative sentiment towards Asians, especially near like March. When, you know, we were gaining more awareness of COVID and there was like blame for COVID on Asians. So here we're just like, it's just another demonstration of like Twitter data being used to try to understand racial climate. But yes, I'm sorry, I wanted to kind of stop at 40 minutes, but so I'm happy to take questions and open that up to discussions. So feel free to like either raise your hand or type things in the chat.
Okay, thank you so much, Queen, for your great presentation. So, you know that I'm just, you know, that taking the question, you know, okay, let me I start with my question, and if we get more questions, we are going to do that. So, you know, one of my questions is related to actually to the misinformation that, you know, that one of the participants, you know, that Denzi will ask it. You know, you said that, you know, that there is no difference between, I mean, that not much misinformation in the racism related, you know, the tweets. I would like to know that whether have you done any experiment to compare, for example, racism tweets with the other tweets to come up with this conclusion? Because you know that one of your data sets were collected in 2015 and 16. And in that time, you know that there were a lot of misinformation, you know, that by Russian bots, you know, and so on. And, you know, that I saw some of the reports on, you know, that polarization and, you know, that working on racism and so on. So I would like to know that how did you conclude that, you know, that in your tweets, or have you done any experiments to compare it to show that the rate of misinformation in the racism tweets is less than the other areas?
Yeah, I mean, I would say that it's not that misinformation is less in the race-related tweets, because I do think that when people speak about race, a lot of it can actually be misinformed. Like for instance, there was like a paper, I think it's a few years old now, but it was looking at like physicians' perceptions of like pain among African Americans, and it found that like physicians like thought that American patients had a higher tolerance of pain um, than other patients. So that is like misinformed because that's factually not true. So with race, I think a lot of racist ideology is misinformed and comes from actually misinformation, disinformation, because it's like not factually true, not biologically true. And so, but then the for us, we like currently we are not looking at whether people are making true or not true statements, as long as like the statements that they're making is like derogatory or negative or like racist in its content. So it doesn't really like we're not like saying true or not true. We're kind of saying like is this have like a high negative overtone. But also in like subsequent models, like in these first model runs, we're looking at like the sentiment. So when a race group is mentioned, is like the tone of it negative, which can kind of cause stress. But now we're actually moving to deep learning models to try to get an even harder modeling test. So is the content racist or discriminatory? And that is a harder test than if the content is negative or not negative. Because it's like saying that it has like racist content, which as you know, racism can come in like very different flavors and can be subtle. So we're trying to run deep learning models to try to get at that. And we're coming up with pretty good model results so far. But these models are harder to run. They require like GPUs and like neural networks. So that paper is going to be probably released in a year or so because like the models will take longer to run and we kind of need them to release them on the data set and stuff. But that's like the next iteration, modeling for racism and not just racial sentiment, although we've had really good results just looking at racial sentiment.
And you know that for your classification, I might miss something. You know that your classification was based on, you know, that identify the sentiment of the tweets. Yeah.
Yes.
And have you developed any classification methods to identify that, for example, one tweet is related to the racism or not?
I think it comes more through in the like qualitative content analyses for themes. So for this the George Floyd paper as well as the anti-Asian paper, we pair the analyses with content analyses of the tweets. So from reading those, we can kind of see what themes they fall under, and like some of them do fall under racism. But that's kind of got at more through a qualitative analysis. Then the follow-up model with the racism detector is also going to be trying to model that if the tweet has racist or discriminatory content.
And you know, I just follow up to on this one, and then I'm going to the question from, you know, that one of the participants, and that question is that, you know, that you focus on positive and negative. How about the neutral tweets?
Yes. So I would say the neutral tweets actually make up the bulk of tweets, because that's generally how, like in these conversations on Twitter, like some of it will be positive, some of it will be negative, and then the most of the tweets are going to be neutral. But kind of what we focus on is like more of the polar ends. It's because we think that that's going to be the potentially like the flag or like the thing that be differentiating geography. So like very like, you know, areas with that have more negative tweets, we think that's going to be informative. But I think we could like look at like neutral tweets. I think we'll see similar associations because we tested both the like seeing negative sentiment, also positive sentiment. We saw like basically it's like concluding the same thing. So if you look at the neutral and how the neutral varies, but then at the same time, if you look at neutral, you can't tell if it's like if for an area, like if you have an area that's 50% neutral, but you don't know if like it has 25% negative, 25% positive, or if it has like 40% negative and 10% positive. So that's where it gets a little like, you might have to have neutral and negative. I don't know. So you kind of have to like play with different categories to kind of see, to try to understand the composition of race-related tweets in an area.
Yeah, it's a challenging, that it's a gray area, so it's
Yeah.
not easy, So you're right, you're right, you're right. Let's go to, that one of the questions from the audience. What are
Uh,
your thoughts on how your social media data results
yeah.
can make a real impact in health and politics at the
Yeah.
practice level and policy level?
Yeah, I think well, when we were trying to like start in this area, I think we were trying to make movements so that because a lot of times when people study like racism, they were kind of just focused on the individual, like has this individual experienced discrimination, and then do they experience worse outcomes compared to an individual who has not experienced discrimination, and that is good, except like those surveys are still pretty rare, and like we don't really get to see as many national patterns, and we don't really capture how racism and cultural racism varies across the United States. And so what we're trying to contribute is understanding of like that variation across the United States, how it's changed with time, and like measuring like a more of an area level influence, like acknowledging that racism is like cultural and societal, and not just so much like not just like, oh, that's just one bad person, but it's trying to like acknowledge the cultural, social elements of racism. And I think that's what we're trying to have impact on like people's understanding. Um, for like practice level, I think that it's highlighting that racism could potentially influence people's health. And as such, it kind of does matter for policy making and resource allocation because it is a factor that can influence people's health. And we recently, like just the last month, we did get another grant. I'm like co-I, my sister's PI. Like I have a twin sister who also does race research, and it's from NIH. It's like a 3.3 million grant from the National Institute for Health and for Minority Health and Health Disparities. So we that grant is to look at Twitter data to understand birth outcomes. So they finally funded it. Like this work was kind of using my funding. My funding is mainly just looking at neighborhood effects, but on the side we did this race research. But now NIH is funding it as a core topic rather than having it be supplemented by things like, because I was already just looking at neighborhood influences. So NIH is signaling, and as you saw from announcements, also NIH is trying to understand structural racism more. So I do think there has been a shift to understanding and contributing to like racism and understanding its effect on health. So I'm happy to see that happen during COVID. Um, and then,
Oh, okay, perfect.
yeah.
Mhm. So the next question is, which machine learning algorithm works the best to analyze your tweets, pros and cons? And I just want to add something because you were talking about the deep learning and that I'm working with the deep learning, but that in my experiment, other methods works better than deep learning. I think that the reason is that this is my actual justification, because that deep learning is usually used for images and very, very large data sets, so that's the reason that, for example, for 1 million and 2 million or something like this, it doesn't work properly. But anyway, that I would like to see your feedback on which machine learning algorithm works the best to analyze your tweets and pros and cons.
Yes. So I feel like this is a great question, and it's been like it's been a few years to kind of learn, and play with, and each data set is different. So what's kind of like potentially frustrating is that when you kind of get interested in a particular topic and a particular type of text, then you will kind of need to kind of experiment potentially with different algorithms to kind of see which one will work best for your data, because the language on Twitter is much different than the language in newspapers or blogs. And depending on the topic, it also varies, right? Because we're looking at race, but if you're interested in like COVID or vaccines or like politics or sports, the algorithm might differ on which perform best for you. So at the very, very first beginning, we actually used a really simple one. It was just like a bag of words. So there's like a dictionary out there. It's like 10,000 words, a LabNT based dictionary, where each word has like a sentiment score, and the algorithm literally just assigns an average to the tweet. So a tweet could have like rainbows, laughter, trees. And that would be a very positive tweet because all the words are happy according to this dictionary. So that's like the first thing that we tried. And the accuracy was like 76%, but F1 score is like 50 something. So it didn't perform that well, but it was like, it's fine. Like it's not horrible. And then the next ones were like, we saw like we used Python, the gradient descent, and then we used support vector machine. And the support vector machine seemed to be the best one that we found so far for sentiment analyses on race tweets. And that can be run on a normal computer without even access to high computational resources. So support vector machines are the ones that maybe I would recommend. They seem to be performing the best. We are delving into the deep learning models for a different problem because sentiment is relatively easy and there are a lot of packages that you can like try. When you're trying to understand like racial content of a tweet, that's like a harder problem to solve. And so that's why we're going into like deep learning models, but the body of tweets that we're running it on is like 30 million plus. So it's like, and if we want, like, that's just like 30 million race related tweets. But if we wanted to run on like all tweets, there's like hundreds of millions of race of like just general tweets. So you do have to kind of get like a big data set, but you also have to get some pretty substantial training data as well. And you only use it if you need it. And we kind of use it because it's like a harder problem to solve than sentiment. It's like detecting racism. And so that's why we use it, but you don't need to use it if you're only going to do sentiment, right? Because in sentiment analysis, you can use a perfectly normal machine learning algorithm for that on a normal computer. So I would recommend that if you can just do racial sentiment, which is fine because it's very robust, as you saw, and linked to like a variety of outcomes. And who knows, with racial, even if after all this effort to try to get the deep learning models to run, it might actually not perform any better than the racial sentiment models. And that's because racism, like that we can detect, is at a lower prevalence than just like a negative tweet about race, right? And like that lower prevalence has implications for whether we can see association with health outcomes, right? Because something that's like little subtle racism that is kind of low quantities we can't really see that effect on health. So we'll kind of see, we'll keep you updated, but that's like the next task.
Oh, it seems that, that we need to try different algorithms for, that different fields. It depends the number of the classes, and the type of the data. Yeah, okay. So let me, that I see, it seems that no question here. I'm going to ask, that my own question. That in slide number 17, you show that something like this, that there was more positive in Vermont and less positive in New Hampshire. And that you see that these two states are very close to each other. So I would like to know that how do you justify, that these two things? So yeah.
So the tweet assigns, each tweet has like a bounding box or set of coordinates. So we kind of know where they are like in. So, but like there is potential error for like people right on the border. So people living right on the border, especially of small states, can like have their like tweet misassigned potentially. But then we think that's generally low, but maybe more important for small states. But this model does allow for states that are side by side to actually have varying sentiment depending on like the viewpoints sent by Twitter users from that state. But we also want to keep in mind like some states have like different numbers of Twitter users. And then so there are caveats, but I think if you're doing research, you kind of just, and here it would summarize over a year period, try to get as many tweets as we could to kind of reliably estimate racial sentiment. So this is like a year's worth of data aggregated at the state level. But so that's like the map that we generated, but still there's going to be variation in the sample size and a little bit misclassification at the boundaries potentially for small states. But the algorithm does allow for variation across geography, even if they're like states living side by side.
And you know that, you work on geotag data, and geotag data is, that less than 1% of the total tweets. So how can we justify that and, generalize, that the result to the rest of the tweets and general population?
Yeah, I would say when I started in 2015, there were actually more geotag tweets. I think people have become like more aware that oh, my location is enabled. I'm going to change that, right? So I think with time, people have become enable location less and less. And so what we're seeing is that more and more selection bias potentially. I'm not sure, I don't think I included that slide, but we looked at where we were looking at like the prevalence of like negative race related tweets among geotag tweets and then among like all tweets that we got. And with the geotag tweets, the pattern was opposite. It was like saying that negative race related tweets declined from 2015 to 2018 if we just look at geotag tweets. But if we look at like all tweets that mention race, which is much bigger than just the geotag tweets, we saw that negative sentiment actually increased across time, race-related tweets. So we trust the all tweets data set versus just the geotag because we know that, it's going to be the bigger one. It's going to be the one that captures more content. But what the weird thing was, like, even though the prevalence is wrong, because clearly the race sentiment is like more negative across time because when we look at all tweets, but when we look at the association between like negative sentiment and health, that was like apparent if we use geotag tweets data set or if we use like just all race tweets. So it's like a bigger data set if we use all race tweets to have at least a bounding box. But the associations were like very similar. I think that was in one of the slides. And that's just showing like it's robust, even though there is selection bias in the geotag tweets, it's still picking up enough of a signal to be associated to the similar magnitude, even with like all tweets. So there's like the selection bias is in estimating the prevalence of something, but it seems to be still correct in estimating the strength of the association, which is weird.
Okay, awesome. So that I just want to see that whether anyone else has any question from the participants.
And people are also welcome to like, I'm at UMD, like University of Maryland, School of Public Health. So if you have any questions, you're welcome to email me and I'll be happy to answer.
That's awesome. Okay, it seems that there is no more question. Okay, perfect. Miranda, do you have any comments?
No, I think that this was fantastic, and the recording can be available with Dr. Nguyen's permission on our website.
Yeah.
Okay, great. Thank you so much, Dr. Nguyen. And I'm so happy that that we finally find you and that you present for our center after 1 year. So and hope to see you again soon. Somewhere in the conferences or the other events. Thank you so much again.